Hey everyone, and welcome back to our series on ECDIS. Today, we're diving into a crucial topic: how your ECDIS actually knows where your ship is. We'll be covering the primary methods of position fixing, the very heart of modern navigation. So, grab a coffee and let's get started. So, how does that little ship icon on your screen move so perfectly in sync with your actual vessel? It's all thanks to a suite of highly advanced positioning systems that feed real-time data directly into your ECDIS. These are what we call the primary position fixing methods. Think of them as the navigators that never sleep, constantly telling your ECDIS, "You are here." The most common and well-known primary source is, of course, the Global Navigation Satellite System, or GNSS. Now, GNSS is a broad term. Most of us immediately think of GPS, the Global Positioning System developed by the United States. And you're right, GPS is a major component, but the GNSS family is bigger than that. It also includes Russia's GLONASS and Europe's Galileo system. So how does it work? Your ship is equipped with a GNSS receiver, which is constantly listening for signals from multiple satellites orbiting the Earth. By calculating the time it takes for these signals to travel from the satellite to the receiver, the system can triangulate its position with remarkable accuracy. This calculated position latitude and longitude is then automatically sent to the ECDIS, which plots your ship on the electronic chart in real time. It's seamless, automatic, and incredibly reliable, which is why it's the backbone of modern electronic navigation. No more manual plotting every few minutes. The system does it for you continuously, but what if we need even greater accuracy? In certain situations, like navigating narrow channels during port approaches or when conducting sensitive operations like dynamic positioning, standard GNSS accuracy might not be enough. That's where our next system comes in: the Differential Global Navigation Satellite System, or DGNSS. Think of DGNSS as an enhanced, more precise version of GNSS. It works by using a network of fixed, ground-based reference stations. These stations know their exact position down to the millimeter. They constantly receive the same satellite signals as your ship and compare the position calculated from those signals to their own known, precise location. The difference between the two is called the differential correction. This correction data is then broadcasted, typically via a radio signal, to DGNSS receivers in the vicinity, including the one on your ship. Your ship's receiver then applies this correction to its own GNSS calculations. The result: it effectively cancels out most of the errors inherent in the standard GNSS signal, such as atmospheric distortions and satellite clock drift. This process can improve position accuracy from about 5 to 10 meters with standard GPS down to less than a meter with DGNSS. This level of precision is vital for safe navigation in confined waters. When you see DGPS or DGNSS displayed on your ECDIS, you know you're getting that premium, corrected position data. Now, let's talk about what happens if we lose our satellite signal. It's rare, but it can happen. GNSS signals can be affected by solar flares, blocked by large structures like bridges or steep cliffs in a fjord, or even intentionally jammed. In these scenarios, we need a reliable backup that doesn't depend on external signals. Enter the Inertial Navigation System, or INS. INS is a completely self-contained system. It doesn't need to talk to satellites or ground stations. Instead, it uses a combination of accelerometers and gyroscopes. Accelerometers measure the ship's acceleration, how quickly it's speeding up or slowing down in any direction. Gyroscopes measure the ship's angular velocity, how it's turning, pitching, and rolling. At the start of a voyage, the INS is initialized with a known starting position, usually from a GNSS fix. From that moment on, it continuously calculates the ship's new position, orientation, and velocity by constantly measuring and integrating all those tiny movements. It's essentially performing dead reckoning, but at an incredibly sophisticated and rapid pace. Because an ECDIS doesn't rely on external signals, it's immune to jamming or signal loss. This makes it an invaluable backup system. If the GNSS signal drops out, the ECDIS can switch to the ECDIS position to maintain a continuous track. However, over time, tiny errors in the measurements can accumulate, causing the calculated position to drift from the true position. That's why on most vessels, the ECDIS is constantly being updated and corrected by the GNSS signal whenever it's available. On high-specification vessels like DP ships, survey vessels, or naval ships, the ECDIS is a standard and critical piece of equipment. So, how does all this information get from the sensors to the screen? It's not magic, it's all about integration. These primary positioning sources, GNSS, DGNSS, and ECDIS are all components of the ship's integrated navigation suite. They are physically connected, usually via a data network, to a central processor and then to the ECDIS itself. This connection uses standardized data protocols like NMEA 183 or the more modern NMEA 2000. These protocols ensure that the different pieces of equipment, often from different manufacturers, can all speak the same language. The GNSS receiver sends a sentence of data containing the latitude, longitude, time, and other relevant information. The DGNSS unit sends its corrected position. The ECDIS sends its calculated position and heading. The ECDIS receives this stream of data, typically multiple times per second, and uses it to update the ship's position on the chart display. In more advanced systems, the ECDIS can even compare inputs from multiple sources. For example, it might have two independent GPS receivers. If the positions from both receivers match, it gives the navigator high confidence in the data. If they start to disagree, it will trigger an alarm, alerting the officer of the watch that there is a problem and that they need to investigate the discrepancy. This redundancy and cross-checking is a fundamental principle of safe navigation. It ensures that you're not relying on a single point of failure. To wrap it all up, the primary position fixing methods are the automated heart of your ECDIS. GNSS provides the standard, reliable global positioning. DGNSS refines that position for high-accuracy operations in confined waters. And the ECDIS offers a self-contained, independent backup for when satellite signals are unavailable. All these systems work together, seamlessly integrated into the ship's navigation suite to provide a continuous, real-time, and reliable position on your electronic chart. Understanding how these systems work, their strengths and their limitations is absolutely essential for every modern navigator. And that's a wrap for today's video on primary positioning methods in ECDIS. I hope you found that breakdown clear and helpful. If you have any questions or want to share your own experiences with these systems, please drop a comment below. We love hearing from you. Don't forget to hit that like button if you learned something new, and subscribe to the channel for more deep dives into marine technology and navigation. Thanks for watching, and I'll see you in the next video. Stay safe out there.